All right, welcome to part 2 of our bacteria situation. One thing embarrassingly I must do is go back and correct my spelling of disinfectant. Probably hand sanitizer is not spelled right either, but we are not going to totally redo the video at this moment in time. So I got my I's and my E's, disinfectant, and I also did it down here. Grab my eraser. disinfectant. All right. Feeling a little bit better about that. Not terribly much, but here we go. The next step is to discuss the R squared. And let's see if I can still paste in. Yes, I still have that. So my R squared is at 58.39, so we're going to make this 0.58. My sentence would be 58% of the variation in after counts can be explained by the variation in before counts as calculated by the least squares regression line of after on before counts. All right, so that tells us our line is fairly strong, but not super strong as far as how helpful it is. Next, I need to calculate the standard deviation of the residuals. The easiest way for us to do that is to use our calculator and go over to stat tests and find Linrig t-test. Change my data lists to the before bacteria count and the after bacteria count. This line doesn't matter. We do want a frequency of 1, and I can put my equation in y1 still. Calculate this up for me. This verifies that A and B that I got. The other nice thing it does is it has my standard deviation value right there for me as well. And this standard deviation value is 3.177. So we're going to make it 3.18. 3.18 is the standard deviation of the residuals. And what does that mean? It is the typical amount, ICAL, spelling typical wrong. So it is the typical amount a predicted after count differs from its it's a typical amount an observed after count. So that's my actual data point that I have up above it in the chart. It's a typical amount and observed after count differs from the predicted after count. And that lives where? On the least squares regression line. Okay. So now we're getting down to the last test, and we want to see what, in fact, do the residuals look like. If the residual plot is scattered, then I'm in pretty good shape for using linear regression. So I'm going to go back to my calculator. I'm going to turn off the equation. I'm going to go to stat plot, and our secretary Beth, when we ran stat calculate 8, so kindly for us put all the residuals in a list called resid. Again, you have to have just run linreg on the data set that you wish for this. And now I can hit zoom 9, and there's my scatter plot. Now, typically we want it to look very scatterish, like a snowstorm. This looks pretty scattered. We do see that there's only a few dots up top compared to the bottom. I don't really see any curving, not necessarily any funneling. That one guy does still concern me a little bit. But down below we have before bacteria counts. And this is going to be my residuals. And this is our bacteria colonies. And again, I will put a scale on my axis using the window function to see what the calculator chose for this. And looking at that, I'm going basically again, let's say from 1 to 20. Let's try this again, from 1 to 20. And this time I'm going from about -6 to 9. So, first thing I notice, number 1, the residual plot is scattered. Therefore, a linear model is appropriate. Now, what about the size of the residuals? Well, we go from a -6 to a +9. That's a stretch of about 15, and if I look back at my original data set, I'm going from 2 to 15. That's a stretch of 17, so my residuals are as large, if not almost larger, than the original data range. So I'm going to say the residuals, and particularly one, are rather large in size. So predictions will not be very accurate. So definitely use caution when we're predicting with this data set. So now my last thing before I make my final decisions is to take a look at that nasty, pesky little point that is a huge regression outlier, this one, regression outlier, and that has the highest after count. It's the highest Y, so I think it's this poor soul who has more bacteria on their hands after they use the hand sanitizer than before. So I'm going to use my stat edit, and I'm going to go take that one out, which is right here. I'm going to delete the 10 and delete the 13. And I'm going to rerun my linreg. I'm going to put that equation in Y2, just so I can show you at the end what effect it did or did not have on the least squares regression line. recalculate. All right, I need that information, but I need it down here in this slide set. So I will use this information, and then I do need to go grab this other information and take a copy of it with me to my other slide. Here we go. Okay. So, let's take a look at all of this. All right, get rid of that white there. Don't need that showing up. Okay, so this is the point 10, 13, and this is before when we had it in our equation, 1.63 plus 0.75x, and my r value is 0.76, and my r squared value is 0.58. And now this is without my 0.1013. My regression line is negative 2.17 plus 0.71x. So we can see that there's a little bit of difference in the intercept, but not very much difference at all in the slope, and the difference in the intercept isn't all that great. The R value goes to 0.904, however, that's a big jump. And the R squared value goes up to 0.82, so it becomes strengthened by quite a bit. So, because it changed the R values more significantly than it did the slope and the intercept, I'm going to claim this is a regression / residual outlier for two reasons. Number one, it had a big residual, so it was in the middle of the data set and it was far away from the line. And number two, removing this point significantly changed the R and R squared values, strengthening the data set, at least strengthening the association of the data set. Okay, final conclusion time. Number one, a linear model is the appropriate choice for this data set. How do I know that? The original scatter plot and the residual plot have no curved patterns. Most importantly, the residual plot. Number two, the least squares regression line has questionable accuracy. It has a weak R squared value at 58%, and the regression outlier 0.1013 weakens the entire strength of the association. Therefore, predict with caution. Okay, again, please excuse my spelling, and I hope this helped you for the last part of our test tomorrow. Have a great evening.